Global Skill Development Council, your gateway to digital transformation. We are an independent, vendor-neutral ISO IEC 1024 accredited certification body committed to helping individuals and organizations stay future-ready in a rapidly evolving world. GSDC is accredited by the Accreditation Board for International Certification Bodies, ABICB. For 10 years, we've certified more than 100,000 professionals across Europe, North America, Asia, and Africa, with our offices in Switzerland, the United States, and Singapore. Our programs are recognized by leading publications and podcasts, including Forbes, Tech Target, People Managing People. We offer 100+ globally accredited certifications across emerging and in-demand domains like generative AI and emerging technologies, HR and learning and development, project management and agile Scrum, ISO and quality management, information security. Each GSDC certification is designed to empower professionals with confidence and help organizations stay competitive in a fast-changing landscape. Every certification is crafted with insights from 100+ global advisory board members representing top universities and leading industry experts. Our certified professionals are trusted by 500+ multinational companies, which help unlock better roles, faster promotions, and deliver.
Hello, dear participants. Thank you so much for joining today's session. We'll be starting a session in next 2 to 3 minutes. We'll wait to join other participants. So, meanwhile, please let us know where you are joining this session from. Thank you so much. Thank you so much everyone for joining today's session. I hope you all can see my screen. Is it visible for all of you, right? So I hope so. Thank you so much for joining today's session. Good morning, good afternoon, and good evening for everyone, wherever you are joining from. So this is Preetham. I'll be here as moderator. Do let me know if you need any assistance during the session. Feel free to reach out to me over the chat box, and I'll make sure that I'll be assisting you. So I would like to give you all a very warm welcome to our webinar series, that is GSDC Certified Learning, GSDC AI in Action 2026, Predict, Protect and Perform across industry, where we'll be learning how to apply productive, secure and high performance AI at scale. So as we all know, we had this incredible panel of speakers lined up for this week, which is started from 19 to 23rd 2026, with the same time slot, that is 7:30 a.m. Central, 9:30 p.m. Singapore, 7 p.m. Indian Standard Time and 8:30 a.m. Eastern Standard Time. Thank you so much for joining all these sessions. So we'll be having the upcoming sessions as well for the next week. So I'll be making an announcement regarding this after this session. So before I could hand over the mic to our speaker, would love to quickly introduce our hosting organization, GSDC. We known as Global Skill Development Council. We are vendor agnostic, vendor neutral. We are globally recognized certification body, and we are accredited by ABICB. So sorry, dear participants, my screen is getting stuck. I do apologize about that. So I was introducing our hosting organization, GSDC. We known as Global Skill Development Council. We are vendor agnostic, vendor neutral. We are globally recognized certification body, and we are accredited by EBICB. We do have 100 plus authorized training partner with us, and I would like to thank you those who have joined us through our training partner channel. In case if you're looking for any training program for yourself, feel free to reach out to our training partner to have an inquiry about it. I'll share the contact details shortly in the chat box. So I'm very proud to inform you all that we do have 100 plus certification portfolio with us, and we have certified more than 250,000 professionals worldwide. We have 1000 plus multinational corporates associated with us, 500 fortune companies and 50 plus universities across the world. I would love to quickly introduce you all to GSTC AI Studio. See, this is a platform where we are providing 100 plus live session monthly basis, which is led by global expert, where you will be getting 4 daily session in that particular month, 45 minutes live experts, which is led by global experts live sessions. And as I said, this is a platform where you will be learning, you will be getting an opportunity to learn from the AI leaders around the world. Real-time practice, which means you can apply all the concept immediately that you have learned in that particular session, and in case if you have any question or doubts, that will be resolved instantly. So this training is aligned with the industry standards for job ready skills. How you can access to GSTC AI Studio in easy 3 steps. So you can start your learning right away for completely free 14 days, where you will be getting access to GSTC, full access to GSTC Studio and 80 plus live session. The next plan that you can go for is GSTC lifelong membership with $109, where we are providing lifetime access, 80 plus live session in that particular month, access to full GSTC AI Studio, free GSTC membership, access to all our physical events and LinkedIn profile improver. The last plan that you can go for is GSTC certification plus lifetime membership with $100, which is limited time offer, where you will be getting access to GSTC certification, all benefits of lifetime membership, personalized coaching, capstone project plus AI tools, GSTC Copilot and assessment tool. You can get in touch with a learning advisor to get more help or more information regarding this GSTC AI Studio. So our current certification portfolio holds certification on different domain, which includes certification on L&D and HR, Gen AI, agentic AI, emerging technologies, ISO lead auditor and implementer, project management and PMO, agile DevOps, SRE, cybersecurity, digital transformation and so on. So this all certification is specifically designed for all the professionals who wants to upskill themselves or looking to stay industry relevant in this AI era, right? So get in touch with a learning advisor for more information, or you can check our website, which is www.gstcouncil.org, to get more information and to check other offerings that GSTC has for all of you. What all benefits you will be getting with the GSDC certifications? You will become GSDC's member for a lifelong. With that, you will be getting certificate upgrade. You will be having free access to all our events, workshop, boot camps, and guess what? You will be getting a free access to all our exclusive learning program. With that, you will be getting implementation resources, speaker invites, and newsletter. Lot of benefits, right? So get in touch with our learning advisor to understand more about these benefits and the certification program that we have. You'll find all the contact details shortly in the chat box. So without any further delay, it is my truly honor to introduce our subject matter expert Ritvik Shetty. He's a GSTC authorized trainer and AI innovation advisor at Solution, and he'll be taking us through the topic, the mechanics of generative AI. Thank you so much, Ritvik, for joining today's session. You can have the handover of the mic now. Thank you.
Thank you, Preetham, for the introduction. Hello everyone. Hope I'm audible to you guys, and hope I'm visible to you guys as well now. And I'll also share my screen. Uh, okay, cool. Okay, is that visible? Preetham, can you just give me confirmation? That would be great.
Yes, Ritvik, we can see your slides.
Okay, perfect. So, good afternoon, good evening, and good morning, everyone, from wherever you guys are. And this is one of my favorite topics about how Gen AI actually works. So, in today's era, what is happening with us is that the knowledge half life has reduced even further, right? So, today you'll learn a new tool, and tomorrow there would be a new one in the market. Tomorrow, your company will approve one tool, and as soon as you start learning it, there would be a new and better tool in the market. But all these tools are based on some basic vocabulary, so basic fundamentals that an LLM has. And a lot of these applications would have an LLM inside them as well. So today we are going through those vocabularies, those words, those nitty-gritties of the basics of how an LLM works. What are the excuse me, what are the different concepts that are involved into it, and I'll try to make it as interesting as possible. There would be a little bit of mathematics into it, not that you have to calculate it on paper. It's just some kind of imagination that you might need to have, and I'll try my best to give you that kind of imagination so that you can implement it in real world. And tomorrow, no matter how many applications or new applications come out, you know for sure in the background this is how they work, and these are the small things that you might have to look into. So yes, so technical knowledge is decaying faster than ever. In 2022 the value was knowing the answer, whereas today it is more about can you orchestrate a solution. So from an example standpoint, initially when I used to interview a lot of people for development, I used to look into whether their syntax is right, whether their coding style is right, whether they are commenting their code properly or not. But nowadays I have changed from that perspective towards a perspective where I ask them more about, I give them a question which is a pre-made Python code, let's say, and then I ask them to use ChatGPT in front of me by sharing their screen, and then tell me how that particular code works. And the only challenge or the challenging part in there is that they can't paste the whole code. They need to paste one single line at a time and then understand it one by one, so that I know what kind of queries they use with ChatGPT to understand that particular code and what is their thought process in that particular scenario. So we have to move on from just knowing the answer of how you sort a particular array, let's say for the easiest standpoint. Rather than doing that, what is the orchestrated solution? What are the different kinds of solution you can do? How can you optimize it? Can you think about um, like the thought process about whether it is memory optimized, whether it's time optimized or not, and stuff like that. So that's how the change is going to happen and is happening in the market. So 2025 is all about orchestrating the solution rather than making it or knowing it. So from doing we are going to reviewing, and from coding we are going to architecting the solution. So operational reality. where AI is getting used nowadays day by day into a lot of MNCs is one is the root cause analysis, where the AI looks through 5,000 log lines, different log lines, and then tries to find the error, tries to find the anomaly into it. Then a lot many times what I've seen developers do is while migrating the code, so let's say your system was based on some COBOL code, which was back, I think it was not there when I was born as well. I think it was then, so maybe in 2000s or something. I've never heard of it. This is an example that ChatGPT has given me, that COBOL would be the ancient language that you can use. So people use it for migration from COBOL to Java or maybe Python, whichever the latest languages. And then there is third scenario where salespeople, where HRs and a lot of people reside here, which is for communication. So a lot of people draft their emails, maybe have a conversation with their clients. A lot of those emails, chats, and all those messages are drafted by ChatGPT, LLMs, and all those scenarios as well currently. So, talking about the landscape, there are three big players out there, and I want you to treat each one of them differently, okay? Because every one of them has their own capabilities. GPT-4o is good at reasoning, so a good reasoner. Copilot from Microsoft 365 is orchestration or an integrator, we can say, because what Copilot has done is connected all the tools, may that be PowerPoint presentation, may that be Excel sheets, may that be Word documents, all of those platforms are connected with one single copilot, where there is the same LLM as GPT-4o or ChatGPT in the background, but the only prowess they have is that they are connected with a lot of tools. A lot of actions could be taken from one single chatbot itself. And then comes Claude, which has its own prowess, of course, for analysis. But what I use it personally is for the Claude code, which sits in my local laptop, again connects with the servers. Nothing that stays local, no processing happens local, but the only thing is whatever action it has to take over a particular code file, rather than doing it on its own server, it takes it on my particular local files. So Claude is something I use for coding a lot. So to dive in deep, GPT-4o is a multimodal. It can, when I say multimodal, this is one of the vocabularies as well. So when I say multimodal, it can see, it can hear, and it can speak, and it can even chat. Okay, so that is what a multimodal model is. And then it has advanced reasoning. Now, why does GPT-4o has advanced reasoning? Is so there is one of the speculations that has happened along the way in the AI industry is that GPT-4o or GPT-5, the ones who are better at reasoning, have multiple small LLMs inside it, which are trained for different scenarios. So one small LLM for medical, one small one for mathematics, another one for HR, and the fourth one for legal, and such eight different, I think eight, that is the right number that I'm saying. So eight different small LLMs are embedded into one ChatGPT 5 or ChatGPT 5 mini. And whenever you ask a query, whichever small LLM is able to answer it better, the query goes to that particular LLM. And then again, it becomes an orchestration behind the scenes. But that is the reason why it has more advanced reasoning. And then it has the world knowledge because it has been trained on a lot of data. Okay, a lot of internet data. Then comes Microsoft Copilot. Again, as I said, it has in the background ChatGPT 4 or 5, whatever it is. You can choose the models, by the way, on Copilot itself. But the only thing is that it is an orchestration. It is integrated with Office 365. And then there is secure graph access. What is that? So it is a Microsoft graph. What it does is whenever you ask your particular Copilot LLM to summarize your file or summarize or analyze an Excel sheet which is stored in your SharePoint or maybe your OneDrive, the only thing that Copilot can do much better than everyone is that it has secure graph access. What it does is, let's say my file is in OneDrive and I ask my LLM to answer from that file. If it's my own file, I own it. If I have the access to it, it's going to read and answer it to me. But let's say there is an organizational file. Let's say it has all the salaries of all the people in the company. Uh, It can differentiate between, let's say, an L1 employee or L2 employee is trying to ask about what is the CEO's salary. The only thing it can do is that it can block them off from having that information, because that file is something that they don't have access to. So that is what Secure Graph Access does in Microsoft Copilot. And then there is enterprise data boundaries. In Microsoft Copilot's enterprise plan, what they do is that they have an agreement signed where agreement in terms of that they will not use the data or any particular conversation, chat, or agent, or maybe files that are shared with it, the knowledge base, nothing of that would be stored with them or used for training further as well. So that is the enterprise data boundary that Copilot has. And then comes Claude, which I use. Again, I use it because I have massive code bases, right? So when it comes to massive code bases, I need a lot of context. Now, again, context is going to be there in the vocabulary. I'll explain to you what is a context window as well. So that basic we are going into. So it has a massive context window, so it does not forget very often. And even if it feels like the conversation is going outside the context window, the only thing that it does is that it summarizes the conversation that has happened till now. Then it makes a chunk out of it and then starts having conversation furthermore. And then again, superior coding ability that it has, an artifact interface as well. Hence it can create a lot of PDFs, and even websites, and even, I'll say, presentations, PPTs as well. So yes, so defining AI literacy, we are going to go through these three steps today. I'm going to try to cover it. I hope I can do it in whatever time is left. So there is vocabulary that we are going to go through, a lot of those. What capability will just have a touch base, and then safety. I want to give you a few examples of how you can be violating the safety guidelines or the GDPR or HIPAA compliances without knowing it. Okay, so yes, let's move ahead. So these are the vocabulary words that we are going to look into today. What are tokens, vectors, embeddings, neural networks, transformers, attention, predictive, generative, context window, temperature, topi, all of these. Okay, we're going to go one by one. If you have questions, we'll try and take them at the end of this session. Okay, so when it comes to predictive, generative, and plus agentic, which is today, agentic workflows is everywhere. Okay, so what is the difference? So predictive was something old. It was used to classify a lot of stuff and forecast a lot of stuff. When I say classify, so let's say if a bank transaction is fraudulent or not, was something to used for classification. It was a binary classification. There were classification for multiple different categories as well. So predictive models or scenarios were used for classification, and then forecasting. So initially the market rate, the market standpoint of a particular stock would be predicted by forecasting as well with the predictive analysis. But nowadays, it is more about generative. We are trying to create new data. So whenever we talk about text, code, images, uh, PPTs, all of these, that's where generative lies. So initially, we would say the only question we could ask was, is this transaction spam or not? But now in generative AI, you can say, write me a reply to this particular client saying blah, 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 and it will write the whole answer to you. And then came agentic AI, which is today, which is not future anymore. I have written future, but it's not future anymore because a lot of MNCs are already implementing those in their day-to-day lives. So the only thing that agentic AI is different from generative AI, that it has become an orchestration which can take actions. So there was one step in between generative AI and agentic AI, which was AI agents. What AI agents were, so generative AI could only suggest, whereas AI agents could take actions over those suggestions. It so we can imagine it as generative AI being the brain of it, but it didn't have hands and legs to take those actions. And AI agents became those the tools in AI agent become those hands and legs to have or take those actions in play. Now, agentic AI is just a collaboration of these agents. Okay. So when it comes to an AI agent to build up, if you use more than 12 tools, more than 20 tools or 20 actions that it can perform, say maybe it can do Salesforce analysis as well, it can have Jira tickets as well, it can connect with your Excel sheet as well. Now that becomes too much load for one particular LLM to think and act. Okay, that's where these big orchestrations started coming into play, where you had one AI agent who works only with Salesforce, one AI agent only with Excel sheet, and other one with Jira, and then there would be a master orchestrator on top of all three of these, where master orchestrator would have conversation with all three of those and make them take those actions and think and plan over the running scenario itself. So it didn't need human intervention on every single standpoint. That's where agentic AI lies. So yes, coming back to vocabulary. Okay, starting with, how does computer look at your input? It does not look at words. Okay, when you say apple, it's going to look at this particular set of numbers. So it's just going to be a simple array or simple list of numbers, right? So that is how computer views your words, right? So if you must have seen this, I'm not sure if it still happens. So try to ask ChatGPT, have this fun activity to try to ask ChatGPT how many R letters are there in strawberry. Okay, most of the times it will go wrong. Why would it go wrong? Is because it does not see how the word looks like. It sees the number it belongs to. Okay, so that is what tokenization is. A token is a fundamental unit of LLM processing. Okay, each word, most of the times, is divided into 0.75% of the word is one single token. So if you have 1,000 tokens, it does not mean that you had 1,000 words into your paragraph. It means that it has somewhere near 750 words. Okay, so 0.75% of the word is one single token. Now, what do I mean by that? We'll take a further look into it. So when I say generative AI is fast, full stop, that becomes one sentence. It has five different words. Now, when I say five, it has generative, it has AI, it has is, it has fast, and then it also has a full stop. So full stop again is a word. Now, when it is converted into tokens, even though punctuation, okay, I know full stop is a punctuation, but then again, for the explanation part of it. So we have five words, but six tokens. Now, how is that possible? So now when I say 0.75%, it can be 0.5% as well sometimes. It depends on what kind of AI model or LLM model you're using and what kind of tokenization it uses in the background. So generative gets split into two different words where gener comes into one token, ative comes into second, and then henceforth. So that is how a token or tokens are generated from the sentence or the query that you give in to an particular LLM. Now, these tokens are the exact value metrics for every single LLM out there. So you get costed for ChatGPT on token basis. Copilot is seed basis, but all the LLMs, when you use their APIs or a developer uses them, they are costed with these tokens. Okay, so you pay per token. So it can be per 1,000 token, per 1 million token, depending on how big or small the model is, how good or bad the model is. So ChatGPT's model, it has, I think, 1 million token for every $0.01, somewhere near that. I might be wrong, but somewhere near that. And the latency, the answer, when you see answers coming in slower with bigger models and faster with smaller models, it's because of these tokens. So the token generation, token decoding, encoding, all these things happen much more faster or slower depending on the size of this model. Okay. Then comes the next word, which is vector embedding. Now, what is vector embedding? It is the next stage from after token generation. So initially, we had generative AI convert into tokens where we had gener and ative in different tokens. Now, just for an example, we had king in one single token. Now, king is converted into this particular vector embedding. Now, what is a vector embedding? Is just a way to summarize that particular word in a vector space. When I mean a vector space, just have this imagination. Think about a graph paper, okay, where you had always drawn a y-axis and a x-axis. You might have done this in your school, maybe once or twice, 10th grade, 8th grade, somewhere. Okay, so you have a y and x-axis. Now think about a z-axis, which goes deep inside the paper. Okay, so you had a z-axis. Now that is three-dimensional. Okay, now think about a space where there exist 256 dimensions. Okay, and 256 is the lower end. Okay, these vector embeddings, the bigger the model gets, they use a lot bigger vector embeddings as well. So it can be 2020 2048 dimension vector embeddings as well. But for now, for simplicity, think about 256 different dimensions. You have y, you have z, you have x, you have a, b, c, d, and going for 256 different characters, maybe ac, and much more further. I know, tough for imagining. I can't imagine it as well. Okay, so that's how long this particular vector embedding gets. So once the word comes in, it is converted into a token, and then a token is then converted into this particular vector embedding. Then comes vector space. So as I told you, think about this space, and the great part of this space and mathematics, which mesmerizes me every day, is that these vectors act in such a great and amazing way that if you take a vector of the word king and vector of a word man and vector of a word woman, and you take king's vector, subtract the man's vector out of it, and add the woman's vector into it, surprisingly, that particular vector, the number or the list of numbers that you get, fortunately and amazingly, because of how good those encoders are, falls near to the vector of a queen. Okay, so that's how this vector space works, and that's how amazing it is, and that's why LLMs have that kind of power to have that next word predicted well. Then there is neural network. Okay, every LLM has a neural network, or a feed forward network is also what they call it, has embedded into it. Now, many of those who have tried to explain these LLMs talk about that where does LLM have its memory? Okay. And it is supposed, or it has been predicted, or it has been um, thought about that this particular memory lies into these neural networks. Now, what are neural networks? Are these small particular units which has weight into it, and these weights are what we call training a LLM model. We define these weights from zero, and then after training, they have their own value depending on whatever the data has gone through them. So whenever you say, let's say, LeBron James, I hope everyone knows he's a basketball player. So I I think I'm confusing, but yes, I think he's the basketball player. So LeBron James is and you ask ChatGPT to give you an answer, and it will predict it perfectly right that he's a basketball player, right? Where did that memory come from? That's where neural networks lies. That's what neural network help with, because LLM training has seen so much data. It has seen so many times that LeBron James is a basketball player. Maybe he's a news article or something or the other. Because of those, neural networks have those memories embedded into them, which makes them predict basketball as the right word, next right word after saying LeBron James plays dash, hence basketball every single time. So initially, in the I can't even say olden times, because this was, I think, near 2010s and 2012s. Uh, there was RNN, recurrent neural networks. What they used to do was have a sequential processing. They could not remember everything. They forgot the beginning of the sentence by the time they reached the end of it. So that was RNN for you back then. But then this was the transformer was something that transformed literally the understanding of everyone and made everyone use LLMs nowadays. That is what transformers did. Now transformer came back in 2017. I think it was Google's team who introduced this transformer in the AI world. The great part about this transformer is the other parts existed, but the one part that it got new was the self attention mechanism. Now, what is self attention mechanism? Right? So, self attention mechanism is something that lets you correlate. And when I mean correlate, think about this. Okay. Let's take this sentence for an example. The animal doesn't cross the street because it was too tired. Now, how does an LLM know that this particular it means the animal and not the street? Okay, because you are humans and you have been trained on English language for so many days, so many years, you know exactly that this particular it is trying to refer to this particular animal as a word. Self attention mechanism in an LLM is exactly that. Okay, it will take each and every word. The animal didn't got divided into three different tokens. You can see that as well, because one was a particular symbol and then T as well, then cross the street. All of them are then correlated with each of the words by themselves. So the and the will have good correlation, but the and it might have certain amount of relation as well. So this self attention mechanism gave you this kind of attention map, okay, attention heat map. Okay, what it did was it had a cross multiplication. The and the got correlated to, let's say, whatever the value is. Animal and the got correlated. The and street got correlated. It and the got correlated. It and animal got correlated. And because of those vectors, it and animal has the highest amount of correlation. Hence, that it is trying to refer to that particular animal. That is what this self attention mechanism and this attention heat map gets to you. Okay, this is the kind of information it gets. Now, because of this, you didn't have to have that one particular sentence in one go. But even if you give paragraph to ChatGPT today, it knows what you are trying to correlate it with what. Okay, what two words are correlated with each other. So that is why these LLMs perform so well. The self attention mechanism and this attention heat map. I hope this gives you a much better clarity. Now, coming to context window. So when I said context window and having large or small context window or all these kind of terms, you'll hear this a lot in today's world. Whenever you go to get demos from different AI vendors, they'll talk about this context window as well. So what is a context window? Now think about this, okay? Many of you might know what a prompt is. You have written a very good prompt. It is a very big prompt, okay? And you had a lot of information stored into it. Now, what happens is every LLM or every language model has a certain size of context window. Some of them has 128,000 tokens. Some of them have 256 tokens. And as big as the context window gets, the better the answers start coming out. But now the computation also increases with that. And when computation increases, the cost increases, and hence bigger models cost you a lot, right? So, what is a context window? Let's say this whole thing is your prompt, including this last part as well. Okay. And your context window sits here somewhere because that's the length of your context window, 128,000 tokens. Okay. Let's consider this as 128 tokens, 128,000 tokens. Now, what happens is as soon as you start conversating with this particular LLM, you keep on conversating, you keep asking questions, it keeps generating answers. As soon as you do that, this context window starts moving further. Now, the context window size keeps the same. The only thing that happens is that it starts forgetting that this initial information that was given to it. Okay, so that is the knowledge fall off, or the fall off that happens in LLMs. So whenever you have longer conversation with ChatGPT, and say you might have mentioned your name as Rutvik in the start of that particular conversation, or maybe you have mentioned that I am a software developer in start of that conversation. As soon as you have conversation, now the context windows have become so big, and now even the summarization is used. So whenever the context window start losing the information, it starts summarizing the context, or the summarizing the conversation, and then keeping the context window alive so that your information is alive. But initially what used to happen was, if I told ChatGPT or any LLM in the beginning of it that my name is Rutvik Shete, and then I didn't mention it for next maybe 15, 20, 30 chats, and then after 30 chats I asked it what is my name, it would forget it, because its context window has moved further. That is what a context window significance is. Okay, then comes why this whole informative session, right? Now, everyone thinks, or a lot of people think, that LLM can take decisions, it can give you good answers and everything. Absolutely right. Okay. But it does not have its brain, it is just a predictive model. Now, when I say it is just a predictive model, I would like you guys to take some part into this, and I would like to see some chats at least. I don't know if I can view those chats while I am presenting, but think about this. Okay, think about this particular one single sentence. Don't read the later part of it, just read this particular sentence and think about what is the probability of these three words coming next. Okay, you don't have anything, you are a blind computer who can just see this particular sentence. Now I have asked you to predict which is going to be the next word. You have eat, lay, and carve. Okay, is there any answers that I can see in the chat box? Okay, it would be great if you could tell me what kind of probability do you feel that this particular words would have. Anything? Okay, cool. So I don't see any answers. So I'll take this forward. Okay, I'll give you the answer myself. So it's equal for all of them. The chicken is ready to eat, the chicken is ready to lay, the chicken is ready to carve. All of these words fit perfectly right. But let me give you a context. Now I show you this image, this particular image. Now, with this context, which word do you think is more likely to be there in that space or that gap? It is eat, right? Now, this particular chicken might not be ready to lay or maybe even carve. So, eat and carve are two words which will have better probability than lay when you see this image. Now, same example, take this into consideration. I'm giving you much more context about this sentence, that I've been roasting dinner. The chicken is ready to. And then now I want you to think about these probabilities. Do you think these probabilities will change? If yes is your answer, then definitely that is exactly what's going to happen. So the eat probability is going to go way high. It's going to say 85%, and that's the word that is going to be predicted by an LLM next. Hence, every time you have an LLM give you an answer, you have to provide it very, very good context, because with that context, it has better predictability for next word. Hence, the eats probability increases. Now, as soon as I keep the sentence same, okay, the chicken is ready to, again, but I change the context. The hen has been sitting on the egg, okay. As soon as I change the context, even my words have changed. Okay, not even just their probability, the words altogether have changed. Maybe the chicken is ready to hatch. Okay, its probability increases. And with this particular image, you know they are ready to hatch, right? So context is everything for an LLM, and it is just a predictive model. So hence, this is how the prediction distribution goes like. So the best way to learn is to, and then you'll have multiple words come up, and the one with highest probability would get printed in front of you, and hence you'll get an amazing answer in front of you by ChatGPT every time. So this is how an inference of an LLM work. Okay, whatever words that we talked about, the vocabulary we talked about. Now let's put it into play. Okay, so whenever you ask a question, what is the capital of France? Every word including France, gets tokenized. It gets an ID. Then it gets vector embeddings. So it get vectorized. And those vectors go into LLM. And the only thing that LLM does well is it gives a probability distribution. Okay. That probability distribution has Paris as the next word predicted with the highest probability. And that's how it answers you with Paris. Okay. And that's how the whole LLM inference works, one after the other. And that's how the loop goes. Now, once it produced Paris, if I asked an elaborate question, how do I write my essay about, or write me an essay about the, let's say, history of AI? Okay. Now, every word it predicts, now along with that word it goes back to the LLM. It predicts the next word comes in, again it goes back, and it keeps on doing it for the next word, next word, next word, and cumulatively keeps going on. Okay. And in that scenario, the context window also starts moving forward ahead as well. Then there are few words or a few things that you might need to know. Okay, so there is this parameter called temperature in an LLM, which is used to give you controllability over whether you want an more imaginative answer or a brainstorming answer, or do you want a very technical on point data extraction or coding kind of answer. So when you have the temperature low, say between 0 to 0.3, you have more deterministic answers. I'll not say 100% deterministic, but more deterministic answers. And as soon as you do it high, from 0.7 to somewhere near 1.0, it goes to become more creative. It will start giving you paragraphs of answer for something that you might have gotten in one single word. So let's say if I had temperature 0 and I ask the same question, what is the capital of France? It will just give me Paris. Whereas if I have it high, it can go for the capital of France is Paris. Paris is good for this, well known for this. It has an Eiffel Tower, blah, 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 blah. So there would be a lot of information, a lot of creative aspects into it. And then comes top P. Now, whenever these graphs or these probability distributions that you get, it has a lot of different words. Okay. In fact, a lot of, I'll say, most of the words from the dictionary that an LLM has. Okay. Now, what top P does is it consolidates it. Okay, it takes a cumulative addition. Uh, Maybe it is better if I show you this particular scenario. So this is what temperature does. Okay, so initially you'll get this kind of probability distribution from an LLM saying that next word should be is. Next particular word should be is. But as soon as I have high temperatures to like implement high temperature to it, the probability distribution will become more random. So your randomness in the answer will increase. So as soon as this happens, the LLM can predict any word rather than just is in the initial scenario. Now it can be is, was, will, or all those things. Okay, any of those. So you have much more non-deterministic answers. And then comes, if you have low temperature, all these probabilities that you had will go down to minimal part of it, and you'll only have is because you just want on point answers. Now that was temperature. When you talk about top P, what top P does is whenever you have top P set as zero point 0.9, it will take a cumulative addition of each word's probability, say is, was, and will. Now, as soon as this goes approximately zero point 0.9 or above that, it will discard all the next words. Now it has confined the output toward these three words. That is what top P does. Now, why is that important? Is when you want more and more precise answer, more and more deterministic answers, that's where this temperature and top P becomes very crucial. But when you want to give answers for an email, you want to write a friendly email or something, that's where lower temperature, higher temperature, and um higher top P gives you better answers, better and narrative answers, creative answers. So that's where temperature and top P comes into play. Now, with all this taught, with all these probabilistic mechanisms, that AI is not, that LLM is just a predictive model, it is not something which has mind of its own. Now, because of this predictability, it can hallucinate. Okay, it keeps looking at the information, but if you do not give it proper context, it will hallucinate. Okay, so if you ask who was the first person on Mars, it's going to say Captain John Carter. Now, why Captain John Carter? Because it took it from some movie reference, some sci-fi movie reference, and that's the pattern it matched. And hence, the Captain John Carter was the highest probabilistic words that could come after this particular sentence. Hence, it predicted wrong. But should we say it wrong? It's just an answer you are not looking for, right? For LLM, it was the highest probable answer. So it's he LLM is right at its point. You failed to give it right context. Maybe on Mars, not in movies, something like that could have been a better context for it to give you the right answer. Then comes training pipelines. These three words, you're going to hear it again and again, day in, day out, if you go and talk to AI people or LLM people. Okay. One is pre training, second is fine tuning, third is, I think it is RLHF, which is human feedback based. Okay. So, what pre training is, whatever LLMs that you get them pre trained. That is pre training. They are trained on massive amount of data. Then now you want it to learn a specific use case. Let's say you are from medical sector, you want LLM to know everything from medical. So you fine tune it. So you teach it exactly just, so you don't want the whole knowledge of the world. You want knowledge for the medical. So you fine tune it. And then HF is something you might have already seen. So whenever you earlier had conversations with ChatGPT, it would give you two different answers and would ask you which is better suited for you. So that was human feedback that it used to take and train itself. So whenever you take the better, softer, polite answer from that particular two scenarios, it will always retrain on those, and hence it became more polite along the way. So that is how the human feedback loop works on. So these are the three different words, and hence why it's polite. So reinforcement learning from human feedback. Okay. So that is what it does. So model generates two answers, human picks the better one, and model updates weights to prefer that particular style. Okay. Now prompt steering. Okay. I think I have some more time. Okay. So prompt steering is something that you tell the prompt, say, act as a senior engineer. Now, many of you have already used it. Why do you think it gives better answers? Because when you say act as a senior engineer, that particular vector of senior engineer goes in that vector space and it sits among the vectors of that particular domain. Okay, so whenever you say senior engineer, it will start using that kind of language into the emails. It will start using that kind of jargons into that email. Just because you said act as a senior engineer, you are steering that particular scenario or steering that particular vector to answer you in that particular scenario. Then comes RAG. Okay, I think this is going out of the screen. Uh, let's just try this uh, and show. Okay, I hope it is visible to you guys. Okay, let me just. Where? Okay, perfect. So, retrieval. What is a RAG? Okay, it is retrieval augmented generation. In a RAG, what happens is whenever you give a document, there are two different phases. Okay, one is ingestion and one is consumption. During the ingestion phase, what you do is you have whatever your documents, the PDFs, your internal documents, you give it to a particular RAG system. It processes the document, it extracts text from it, and then it goes to the embedding model. What is an embedding model? It takes token and converts it into that vector embedding. Now, when it goes to the embedding model, it gives those vector embeddings or document embeddings that you can call, and it stores those vectors against that text. okay, those vectors against that text. Now, when it goes to the inference phase or the consumption phase, a user asks a question to the chatbot. That query goes to the same embedding model, gives you some kind of similar vectors, and now what you do is find the closest vector inside your DB or your database, and then it gives it to LLM saying, "See, I found these particular sentences in this particular DB, and this is how." This is something that you can give information from. Okay, and then that LLM gives you a better answer. So rather than going further on this presentation, I would like to give you this particular demo. You also have this as an task after this particular session. So pay attention. It is fun. I love this. I love this website a lot. Okay, whoever has made this, thank you for that particular person. Okay, so let's say you have this particular text in your document. It is your internal document. At OmniX Systems, the Infinity bonus, something called Infinity bonus, creates a payout of $10,000 for every year of service. And this applies to all full time staff in the Alpha sector. However, consultants in the Delta squad are strictly excluded from the Infinite bonus due to their temporary contract. Okay. Now, think about this. This is your internal document, and you had this feed into your RAG, and now you want to ask questions. The important parts of this is how do you chunk the text. Okay. So say this, I have done this 20. Okay. What is 20? It's the character length. Okay. The maximum character length before the sentence ends or new sentence starts, before I split words into two, I want it to be 20. Okay. So at Omni X, which becomes 18 characters, came into one, the came into two, second one, infinity bonus into third one, and furthermore. Okay. That's how these words are defined. Now, think about how these vector embeddings look like. Okay. Now, I want to ask a question. I am a Delta squad, the squad which does not get that kind of bonus. Okay. I am in a Delta squad. Do I get infinity bonus? Okay. This is the question your team's person asks your rack system, right? This is what happens. So, as I told you, there is a graph system where every point is marked. And now in RAG, what they have done, they are marking those chunks rather than single words. Now they are marking chunks. Now, this is your query, okay? You can see it here hovering that I am in Delta squad and the whole sentence is there. This is where my vector lies, okay, in this particular graph space. And then there are these vectors which are close by to it, okay, which is the closest that I can see is this one, chunk number 3. So because I had asked infinite bonus in the question, the similar chunks, okay, these are all the chunks that are there. These are chunk embeddings that you have, and these are the similar chunks to the question that I have asked. So the chunk 3 seems to be closest. Now, why is it closest? Because chunk 3 included infinity bonus into it. Then I look for chunk 15. So chunk 15 is next closest one. It also has infinity bonus into it. Then comes chunk 12. This is chunk 12. It has delta squad into it, which was in my question. So hence, it will look for all the closest chunks and give me these chunks which are closest, way much more closest to it. Now, what happens next after RAG, as I shown you in this particular diagram, that we had this embedding, we found this, which are the closest to our vectors. Now, these vectors go to LLM. Okay, the closest one, the closest top 5, top 10, whatever you want to choose, goes to an LLM. Now, I have chose here top 3. Okay, not I have chosen it. This particular developer has chosen it, and it is amazing. So the only 3 words got to it. Okay, and now I ask the same question. I am delta squad. In delta squad, do I get infinity bonus? And I generate a response. I don't get a response. Why do not get the response? It got the documents, it got the context, everything was right, but I don't know enough information to determine if you're qualified or not. Now, why is that? Now, it is exactly because of this chunk size. That's how important a chunk size is. Let me give you an example. Okay, now I did as 100 characters as my one chunk. Okay, and I said an overlap of 50. Now, what does overlap of 50 mean? So I'll have a 100 character chunk. Okay, this is my 100 character chunk. It has 99 characters, by the way. Okay, out of which, from payout, okay, from this word payout, this part also has gone in the second chunk as well. So there is this overlap of 50 from payout to this. This set of words are overlapped in chunk 1 and chunk 2 as well. Now, why is that important? To have that context maintained, okay? If your sentence gets breaked off in between the sentence, you don't know which sentence the second one belongs to, okay? Because you're going to have a lot of documents in there. Hence, the overlap is quite necessary. So I have 100-word chunk, out of which 50 are overlapped, and then 50 overlapped for the next one, 50, 50, 50. Now I go to this vector embeddings, have the same question. Now it has these particular vectors which are close by to it. Okay. Now, if you see, the chunk number 5 is close by, and the chunk number 5 includes the Delta squad are strictly excluded from Infinity bonus due to their temporary contract. Okay. You can even see it here. Chunk number 5, 1, 2, 3, 4, 5. Yeah, the Delta squad are strictly excluded from, and then there is 5 year. Sorry, this one is the fifth one. The Delta squad are strictly excluded from the Infinity bonus due to their temporary contract. Right. So you have chunk 5, which is the closest to you. And now, when you go for a response, now you have these three chunks that came from your vector or the RAG, the retrieval system. And now you ask the same question to generate the answer. It will give you a strict answer saying, no, you don't get infinity bonus. According to the information, the Delta squads are strictly excluded from the infinity bonus. That's how important the chunking and the overlapping of a RAG system is. Now, there are more complex algorithms around this RAG that are useful, that people have been using in production. So you can go through those as well. Even here, they have used three of those: parent, child, fixed characters. They have given example of or information about what those are. And in the challenge that Preetham would be sharing with you, all these will be the link for this particular website would be included so that you can try that particular experiment as well. So yes, we went through all this vocabulary. I hope you got all of it. We have few more things to be discussed, but before that, if you have any questions, it would be amazing to take those questions first, and if there are none, then we can move ahead, cover a few more grounds. Are there any questions that we can have? Are there any? Amazing. If there are none, that means my explanations were good enough that you got it. Okay. So I'll take that as a tap on the back for myself and then take a few more things. We have, I think, 1, 2 minutes. Okay. We'll just touch base on those. So, capabilities of AI: it can process, summarize data, create images, content, drafts. Okay. Rafael has a question. I think that is Raphael. Sorry if I pronounce your name wrong. If you could write that question in the chat box, that would be amazing. Till then, I can cover a few things. Uh, so yeah, automating routing. Then we have translation languages. That's all where LLM is. Then there is where AI can't be used is to have defining definitive answers, factual accuracies as well. If you provide right context, the factuality increases of the answers. Making high stakes or complex ethical decisions, that's where AI can't be used or shouldn't be used. And replacing human judgment and oversighting entirely, that's not what AI can do right now. Right now, okay, that's the keyword. How can this LLM strengthen public procurement process? Okay, there are two different questions. Let's go with Madhu first because that question was first. What are the practical difficulties normally in any AI and normally any AI architect faces? Okay, so then in the difficulties that you can go through, one is computation. If it comes to locally deploying this particular LLM or any of those scenarios, the problem that happens is deployment. Okay, LLMs are heavy. the decision making between. So use case, if the use case is big enough, you need to deploy a very big LLM. Okay, if it is small enough, if you have fine tuned that LLM, you can deploy a smaller one. But then comes cost argument. Okay, people say that if I use a larger LLM, it's going to give me answers, I save on fine tuning cost, but then I get a recursive cost of deploying that LLM on a H100 or some kind of heavy GPU. Okay, whereas I can put a one time fine tuning cost. It is not one time. Many of the times model fall out as well, they get outdated, so you have to fine tune them again. But it is a cost that you procure, you go through, you fine tune it and then start using it and then go further ahead. Okay, so that differentiation or that decision making is something an AI architect would face the most. It is very difficult to explain it to higher ups why this particular GPU is needed, and even after getting that GPU, why can't you handle those many parallel requests? And if you go to them with the smaller model, they ask about why is this not working well? Okay, so that is the architectural point 101. Where do I deploy? How do I deploy? Where do I inference? How big the model should be? And then the second one comes up to be for the rags and all these sub questions, where how much chunking should I do? Should I have a graph rag into it? Because graph rag is also a concept. So should I have graph rag into it? Then that becomes a question. But initial thought process always is how am I going to deploy this? And if it is to be in-house, what do I do? So that is the practical difficulties normally and any AI architect would face. Uh, Rafa, Raphael's question is, how can this LLM strengthen public procurement process? I'm not very sure about what do you mean by public procurement process or where you are using LLM into it. But in sales perspective, if it is sales, you want to retain a client or you want to get new client on board. This is one of the examples I give at most of the um, m- uh, MNCs, is that think about this, that you have an pitch deck. Okay, you have a pitch deck and you want to go to the client and you want to give a very good pitch about what you can sell. Okay, that is old way, right? You have a pitch deck, you know your features, and you go and you explain your features, then they think about whether they want to buy or not. But think about this scenario, that you have an LLM and now you have a podcast or maybe their past documents or something like those from the client. Okay. Somehow you scrape through the internet, you got that information about one particular client. You fetch that information, you give it to your LLM through RAG or through maybe even in the chat if it's small, through RAG, let's say, and ask the LLM, what are the pain points of this company? Okay, where are they lacking? And then LLM will find those anomalies. Maybe their CEO has mentioned in his podcast that they were facing difficulties in some southeastern eastern countries regarding the trade or something like that. And then those problems becomes your motive. Okay, you go to that call and you start not by saying that these are the features that we offer. You start by saying that these are the problems that you might be facing, and these are the solutions that can help you accept those. Okay, so that's how an LLM can be useful in your sales kind of language. I'm not sure if that was the right interpretation of the question that you gave me, but that's how public procurement can be process, like in public procurement process, LLM can strengthen your standpoint. So I hope I answered your question. And Preetham, do we have some more time or do we have to move on, or else I have to three?
Ritvik,
Yeah.
you have three. Yeah, you may complete all the slides. We can extend the session for 5 to 10 minutes. That's absolutely fine. Thank you.
Okay, perfect. Perfect. Okay, so let's have this last part. Okay, the safety agenda. We'll go through it quickly. There are two different norms. Many of the people know GDPR, HIPAA. I don't have to explain those to you. They are there. One is right to be forgotten and automated decision. Another is other is about the healthcare sector. Okay, GDPR, the right to be forgotten paradox, is something that happens So user can request a full deletion of data anytime, okay? And your system has to be capable enough that it deletes that data. That's when you are GDPR compliant. But that's not the case with the LLM. There is a training trap, okay? If you fine tune a model, let's say a simple model, a small Llama 3 model, using a data set which contained the customer's personal information data, somehow it got in there, okay? And the customer asks you to delete it. You can't delete a small memory from the whole LLM. Okay, you have to discard the whole uh, model altogether, and then you have to fine tune it again without that data, and then you'll have that model. So your cost of this particular fine tuning, the earlier fine tuning, has gone to waste. Okay, so for this, the solution is you use RAG every time, so that whenever you want to answer particular user or personally answer that particular user, what you do is get information from your RAG database, the vector database that you had, and then you answer it. And whenever that particular person asks you to delete their data, you can just delete that data from that vector database, so it does not have your information anymore. So RAG is something that can fix this. Then comes Article 22 from GDPR itself. I'm not sure it is Article 22, but Article 22, uh, which says that user has the right not to be a subject to be purely automated decision with legal effects. Okay, so in even auto rejecting alone, okay, you need to have human in the loop. You always need a human in the loop. So if you don't have a human in the loop, you are violating GDPR, right? Because you are letting AI take automated decision over someone's life that is legally affecting that particular person. Now, what is the solution? Again, as I said, human in the loop. Then in HIPAA, there is mosaic effect. When I say mosaic effect, what happens is, let's say you might have redacted this name called John Doe, okay, but you leave this uh, information saying that he's a male, 45, diabetic, zip code 90210, appointment on Tuesday, okay. Now, AI, because it is a prediction mechanism model, it can predict well, it can correlate well, okay. And when I say correlate well, the self attention, as much as it is a boon, it is also a sad part that it can create that mosaic effect. Now, because it has a zip code somewhere in the address section, maybe you didn't redact John Doe and his address is mentioned there. AI is well and good enough that it can correlate this particular zip code in only this information, and correlate it with John Doe's address in some other information, and then exactly know that John Doe is that particular male who was 45, who is diabetic. And this mosaic effect can cause you a lot of damage. So be careful about this. Be careful of what you're redacting and how much you're redacting, and redact as much as possible. Okay. So then comes, somehow your support manager pastes a messy patient's email chain altogether into ChatGPT free account. Okay, to clean it up. And just to clean it up, he has pasted it. Now it is a public data because ChatGPT is going to use it to retrain their models later on. Hence, what the solution for this is: private enterprise instances. Azure provides it, even ChatGPT provides it, Microsoft Copilot provides it as well, which they have signed a BAA, which is Business Associate Agreement, so that they don't use that data anywhere to train or even to give out, hence use those. Okay. And de-identification failure, again the same point, just like GDPR. You trust the AI to remove all the PII data, but it does not. It might miss the name 1% of the time, and that 1% is a federal crime. Okay. So be careful and try to use Microsoft Presidio. Okay. It is maybe your developers already know it, but that is something that uses regex and stuff like that to redact information from paragraphs. So that is something you can have as filtration part between the LLM and the human. So whenever they ask, or whenever you have something coming up, data coming up as an input, you can have it in between so that it filters it out and redacts the information. So yes, this is the summary. We went through the paradigm shift of from moving from technical knowledge to orchestrating it. Then we just demystified the engine, how Gen AI is a probabilistic prediction engine built, and then what are tokens, vectors, transformers, what is the math? It's just a math and not math, not magic at all. Then we steering the model, how to control the output through maybe effective prompting, the temperature, the top P that we discussed about. Okay. Then navigating through the risk and ethics, how we had hallucination, how we had training bias as well, GDPR, HIPAA compliances, how we can break them in day to day life just without knowing them, unknowingly, actually. And then the human element, the RLFH align model, so that it aligns with human values more, and human remains a legal decider and essential for safety. So I hope this session was helpful to you. I hope you got to know a lot of jargons. I hope you got picture in mind for a lot of these words, because these are the crux of the matter. These are the pillars, and whichever solution, whichever software that is coming next are dependent on these particular factors as well. So thank you guys for listening to me blabber for 1 hour, and hope you got something out of this. And please do try this particular website. It's amazing for your understanding of RAG, and give it a try. Thank you.
Great. Thank you so much, Rutvik, for another amazing session at GSDC. And we're really glad to have you as a subject matter expert. Looking forward to have more sessions with you. And before I take the handover back of the mic, I would love to hear final thoughts from you for all our participants, and then we can proceed with the amazing announcement that I have for the participants. Thank you.
Okay. So, final thoughts. AI is here to stay. Okay. Everyone has been saying this, but acceptance has been low into by people. Even when my friends in IT but non background from AI, I try to persuade them that learn AI, get into AI, think about it, how it works. Maybe try to implement few of those things. The only thing that AI is bringing is more and more exoskeleton to you, okay, so that you can do the heavy